All right, so chapter 3 is going to cover body membranes. You can see those first couple of bullets are just general functions of membranes. They cover surfaces of the body, they line our body cavities, they form protective sheets around organs to help to retain moisture. They act as a barrier against things that make us sick or are considered pathogenic. They hold our organs in place and help to lubricate organs in order to reduce friction. There's two types of membranes. They are either epithelial membranes or connective tissue membranes. If it's a connective tissue membrane, then it's just that. It's only connective tissue. If it's an epithelial membrane, then it's going to be comprised of both epithelial tissue and underlying connective tissue. So there's 4 types. Mucous membranes are the first ones that we're going to cover. They're often called the mucosa. Okay, and they open, let me let that refocus for a second. They open to the outside of the body. They notice the spelling of mucus, M-U-C-O-U-S. Okay, that's the name or the spelling for the membrane. And then notice M-U-C-U-S, that's the secretion, the spelling for the secretion. So you have to make sure that you've got those not mixed up, okay, that you know the difference in the spelling. So mucus, just think snot. It's thick, it's viscous, and it's going to be a secretion to retain moisture. Mucous membranes are composed of both epithelial tissue and loose connective tissue, or that areolar loose connective tissue. Type of epithelial tissue is going to vary based on location. So these are just a couple of examples. Lining the respiratory tract, the digestive tract, the reproductive tract, and the urinary tract. And then you've got just some specific organs listed there as examples within each of those tracts. Functions, just again, kind of general here, to lubricate food and waste, to trap pathogenic organisms, okay, viruses, things like that as well, bacteria, viruses, fungus, secreting enzymes, absorption of food. Okay, so those are just still kind of general, okay, but just think respiratory tract, digestive tract, female reproductive tract as far as the oviducts being listed there, and then the urinary tract. The next type is a serous membrane. Okay, so let me shift that real quickly. So serous membranes are often called the serosa, and they do not open to the outside of the body, and they are made of simple squamous epithelial tissue and loose connective tissue or areolar tissue. Here's some locations. Okay, the pleural membranes around the lungs, the pericardial membranes around the heart, and the peritoneal membranes in the abdominal and pelvic regions. Right, in general, just we say that they are to prevent friction and to provide lubrication, because organs are going to move, okay, and so we need to reduce friction and they need to be lubricated in order to help to reduce that friction. All serous membranes have 2 layers to them, so they always occur in pairs, and between those 2 layers there's serous fluid, which is a water-based fluid. So the parietal layer and the visceral layer are the 2 layers. So let's use this little analogy here to help explain this. Okay, so if you blow up a balloon and then you shove your fist down into it, then your fist is like the organ itself. So the layer around the fist in the picture, that's the visceral layer. It's the layer that covers and adheres to the surface of the organ. The space where the air is in the balloon, that's where the serous fluid is going to be located. And then this outer layer of the balloon, that's the parietal layer. It lines the wall of whatever cavity the organ is located in. Okay, so the parietal pleura, sorry, wrong diagram, parietal pleura will line the wall of the thoracic cavity around the lungs. The parietal pericardium will line the wall of what's called the mediastinum around the heart. Okay, and then when we go to this other diagram on the bottom, you can see all of those labels over here on the right. Okay, there's the parietal peritoneum, and then they're showing the visceral peritoneum adhering to the surface of the stomach. Right, and so then over here between this visceral and parietal layer, you would assume that there's a thin watery fluid, and then there's the surface of the lung, for example. Okay, so then next, the cutaneous membrane. All right, so the cutaneous membrane, this is the only dry membrane, so this is your integument or your skin. So we're going to go into much more detail on this than what we see here, so I'll keep it short and sweet. So this is keratinized stratified squamous epithelial tissue and loose areolar and dense irregular connective tissue that make up the skin. Right, as far as functions, this is just a few general functions. Again, more detail to come. So this is our first line of defense against fluid loss and infection. Helps to protect against traumatic things such as an injury. It helps regulate body temperature and then provides sensory information. And then the final type of membrane is a synovial membrane. Sorry, I keep scooting that too far. A synovial membrane. So this is just connective tissue in synovial membranes. So it's loose or areolar connective tissue and then some adipose. As far as locations, at joint cavities, between the ends of long bones. Okay, so you'd have serous fluid in the middle of that cavity, right? And then it's lined with loose connective tissue and adipose. At the knee, the elbow, the shoulder, and the hip specifically are being mentioned there, but essentially at the ends of all your long bones where they meet. And then the meningeal layers cover the brain and the spinal cord. And so there's three layers: the dura mater, the arachnoid mater, and the pia mater. So the dura mater is the most superficial. The pia mater would adhere to the brain, like in this diagram here, for example, and then the arachnoid mater is between the two. And as far as functions there, that's for lubrication of organs and joints, helps to reduce friction, and provides nourishment for cartilage to keep it nice and functioning, essentially, because it's got to be a little bit wet or moist. And then synovial fluid is thin and water-based. Let me know if you have questions.